All right, so our next speaker is Ilari Korhonen from KTH, Royal Institute of Technology. His title is Deployment of a National Research Data Grid Powered by iRODS. You have a mic on the stage.
Hi, thanks. So I'm Ilari from Stockholm, Sweden. Can you hear it? How about now? Does it work? Good. So yeah, I'm representing KTH and also SNIC at the same time. SNIC is a member of the iRODS consortium, and we as a KTH Supercomputing Center are a member of SNIC, which is our national infrastructure for HPC. So, some background. I have been talking here before on behalf of KTH and SNIC as well, but maybe somebody have not heard this before. So 2017, basically we got a funding decision from SNIC to actually deploy this system in production. And previously SNIC has been running for 5 to 10 years or something like this, quite large distributed storage system called SweetStore, which is based on Dcache, which is popular in the particle physics community. But now we'll be running both Dcache and iRODS in parallel. And basically what we are starting with is 2 times 1 petabyte of storage distributed at KTH and NSC in Linköping. And at KTH we have already deployed everything, and NSC in Linköping University is still finalizing their deployment. At PDC we are running GPFS for iRODS backing storage. So we are basically using this as a high performance or semi-high performance landing zone for data ingest from our clusters. So something about our software. We're still running iRODS 4.1, and we will need to upgrade to 4.2 as soon as possible, but I still have lots of updating to do in my deployments. And like many others, we are using Postgres streaming replication in the background. Just CentOS, no Red Hat Enterprise. We're very happy with CentOS. For user interfaces, we use iRODS for WebDAV and anonymous publishing through HTTP, and also Metalinks for a web interface. And also we support, of course, Kanki for native UI. And we are basing our identity management in FreeIPA. We're using LDAP and Kerberos, federated against KTH Kerberos, so our local users can nicely log into the SNIC zone. And we have integration from FreeIPA against iRODS to provision users and groups and projects from the national project management repository. And for file systems, we are using ZFS extensively and GPFS and also TSM for our tape libraries, both at PDC and NSC. And our sources are in GitHub and Git repositories. And we have a Sphinx repository for documentation, and we use Vagrant and Ansible for deployments and testing of the deployments. So basically what we are doing is we're running a somewhat geographically distributed data grid, which is quite cost effectively highly available, because if Stockholm ceases to exist, there's still Linköping, which I'm hoping won't be the case. And we have a distance of about 130 miles between our centers, so there will be some latency, about 3.4 milliseconds as far as I remember. So we need to do replication asynchronously for performance, for both database replication and for storage replication as well. But luckily we have a pretty good network backbone in Sweden. It's called SUNET, Swedish University Network, and they are running at 100 gigabits link speeds. And basically this is one of the status graphs when we were trying to light up the fibers a bit, somewhat successfully. But some links are still at 10 gigabits per second and some are at 40 gigabits per second. But KTH we are running now at 2 times 100 gigabits per second to SUNET, and at locally at center too. And our file system is connected with EDR InfiniBand at 100 gigabits per second. So we did some testing. From Stockholm to Lund, which is in very, very southern Sweden, at the southern tip next to Copenhagen, we got about 1 gigabytes per second on average, but they had basically a 10 gigabit link somewhere in between at the host interface or something like that. And through NSC, which has a 40 gigabit backbone, we got on average about 2 gigabytes per second with half the latency. And at PDC locally over our local 100 gigabits fabric, with reading from GPFS, writing to GPFS via iRODS in the middle was up to 8 gigabytes per second, between 7 and 8 gigabytes per second, depending on the phases of the moon and the spots on the sun. And basically we have been slowly rolling into production, phase by phase, trying to multitask and all. So we also had to do a couple of data migration projects in parallel. So basically there was 2 legacy systems that we need to migrate, one at NSC and one at PDC, 96.6 terabytes total, and about, 5.5, close to 6 million data objects. So basically we are starting with almost 100 terabytes of legacy data and legacy users. And we also have new users that have applied to the new system, and their applications have been accepted. So I have to, give some compliments to the iRODS data migration because it makes our life very easy. So basically we had this, our old, now to be decommissioned iRODS zone, and we had to migrate some groups off of the iRODS zone to SNIC zone. So this was pretty nice because we are running federated, so basically what we did was, or I did, was that I just basically imported the super user at SNIC zone to the iRODS zone, and then modified access control list to say that, okay, the super user in SNIC now owns everything, and then IR-sync to simplify it a bit. Of course, I had to do many steps in between and parallelize the process with many long-running jobs and so on, but basically IR-sync did the job over zone federation. 2.5 million files. Checks on validation and all, end to end. So I could show you some semi-live demos. I was supposed to give a live demo, but there is an issue with the DNS resolver at PDC, so it will be slow. There might be some latency to the DNS being slow. So basically what we have is we have 3 federated zones, the old iRODS zone, PDC, KTH, SC local zone, and SNIC zone. And what I did now is I logged in via Kerberos. And I did it from our local KTH realm. And these realms have a cross-realm trust from not a KTH SE to SwiStore.se. So now I'm in the SNIC zone through my KTH Kerberos credentials. And if I want, I can also go to the PDC zone, of course, with my PDC credentials through SNIC iRODS if I want, of course. It's a nice round trip. And just a quick look at the resource tree. So we have an to be deprecated SNIC disk hierarchy here. And then we have some migration resources. And then there's a GPFS resource tree for GPFS file systems. And then we have some temporary resource trees for data migration at NSC. So pretty straightforward. So something about our application process. So basically we have this SNIC users and projects repository called Super. And when users want to apply, they go to Super, and then they pick around, like a small Swiss store, and we have here resources, Dcache and iRODS. And users just basically select what kind of resource they want, and they describe their project and try to apply for storage. And then somebody approves their application or disapproves, declines. When they're accepted, the user gets an email that, okay, your application was accepted, please go to our identity management and reset your password. And then he follows this link, and my colleague in Linköping wrote this authentication interface for free IPA, which does an external authentication against Super. So I can use my bridge certificate here to prove my identity to this free IPA. Now I could reset my Kerberos password, which I'm not going to do. And after that, the user gets an email that, okay, you are now a new user, your project path is over there, for documentation please go there, and so on. And then our admin team gets an email from the integration module that, okay, new project and group has been approved, and users have been created, groups have been created, and so on. So the module basically provisions new users and groups and projects to both free IPA and iRODS. So everything comes to place automatically. And for user interfaces, we have, as I said, metalinks for a web interface. And then we have iRODS, which we also use in anonymous mode for serving our documentation, for example. This is coming from iRODS, of course. So we have our documentation rendered to HTML within iRODS and served from iRODS via WebDAV. So iRODS became a web server. Why not? And basically, we also have a nice GitHub hook here, so we can edit the source in GitHub and just commit there and then push to iRODS. And we have some source repositories publicly in GitHub if you want to go and take a look. We are publishing something that we have been doing, like TSM interface, for example, that my colleague wrote in Linköping, and some other smaller utilities for iRODS, and our provisioning codes and whatnot, miscellaneous things. They're open sourced with BSD license. So I guess I just want to give my thanks to my team and provide you with their contact information. And basically we are a very diverse team. Working in Sweden, we have a Finn, we have a Bosnian, we have a Turk, we have a Hungarian and an Indian. So if you have any questions, I guess I'm done otherwise. No questions. Enough said.